Hey everyone, so this video is for the similarity and similarity transformation tutorial and mastery test. I'm going to start off talking about what similarity is, then I'm going to work you through the GeoGebra. I'm going to tell you to cut some of the stuff of the tutorial out because I don't think you need it. So kind of pay attention to what I'm telling you to do and not do, especially with the GeoGebra and the activities. And I'm going to show you a little shortcut trick as well. So first thing is, what is similarity? Now, if we think about congruence is two figures are the exact same shape and size. Everything about them is the same. All right. Similarity is two figures that are the same shape but different sizes. So let's think about our transformations that we've done, focusing on the big four. So the big four are translation, rotation, reflection, and dilation. Those first three, translation, rotation, and reflection, whenever we did those, the size of our figure or the shape of our figure was never changing. So as you saw, those were called rigid transformations, right, where it's never changing. The only one that ever changed the shape of our figure was dilation. And when we dilate, it either enlarges or gets bigger, or it gets smaller. It's called reduction. So dilation is the process of enlarging or reducing your figure. Now it still keeps the same shape. All that's changing is the size. So that's going to be a very important concept to understand. Now with congruence, all the sides that are corresponding mean the same relative position, all the sides are congruent. But not only are the sides congruent, the angles are congruent as well. When we dilate, the side lengths of our figures change. They change by what's called the scale factor. So the scale factor is how much bigger or smaller your figure is going to get. If your scale factor is greater than 1, it's enlargement. If your scale factor is less than 1, that's called reduction. Now what doesn't change though is because our figures are keeping the same shape, the angles will stay the same. So because everything's moving in the same proportion to that scale factor, the angles for similar figures are still congruent. That is a very important concept. So let's take a look at your first activity kind of in GeoGebra. So you'll go to slide 6, and then eventually you'll click on this right here, and that's going to take you to this slide. Now at first you're like, wow, it's a lot of different shapes. Okay, or a lot of figures. And it is, it's 5. But what I want you to notice is they're all the same shape. They're just different sizes, or maybe they've been rotated or reflected or translated, but they've all been dilated because our original figure is this orange one right here. All right, so somehow they did something to get it to blue, to gray, to red, and to green. So the two I want you to focus on are the blue and the green. We're not going to deal with these two at all. Only blue and green. All right. So the first thing I'm going to zoom out a little bit. It's going to make it a little easier to see. And if you look back at your directions, they're asking perform dilations and transformations to make them match up. But I'm not going to have you do that for all 4. I only want you to focus on doing it for 2. Again, the blue and the green. So I'm going to do blue with you, and then you're going to have to kind of practice to see if you can get it to match up with green. All right. So they're asking what is going to be done to get KLMNP from ABCDE. All right. So the first thing I notice is that the blue is bigger than the orange. So I need to dilate that. So if I go over here, this right here is my transformation one. So the one with the 2 rays and a blue and a red dot. So I'm going to go down to dilate. So notice it says to dilate, I have to select an object and select the center point. Now, all of our dilations are always usually done from 0, 0. So, but if I am just on the arrow selector, notice when I hover over 0, 0, I can click there, but there's no point there. So the first thing I want to do is I want to enter a point at 0, 0, because that's going to be where I can select the point to dilate from. I'm going to go back now to my transformations. And notice it says at the bottom, it says select object, then select center point, and then enter your scale factor. So I'm going to click on dilate from a point. I'm going to click on the object I want to dilate. I'm going to click on the point I want to dilate from, and then I'm going to enter in my scale factor. Now I'm going to enter in a scale factor of 1.5 to start. So 1.5 times bigger. Let's see what happens. Now if I compare this new orange figure to this blue figure, I notice that the orange is still smaller than the blue. So that means my scale factor wasn't big enough. So let's redo that. I'm going to go backwards. I'm going to do the same thing. Click my figure, click my point of dilation. Now let's enter 2. I'm just going up by half. Now it's kind of hard to see, but follow the blue outline. That's our original figure, the blue outline that we're trying to match up to. This orange one right here is what we got after dilating this figure by 2. So notice that the orientation, meaning they both look like they're in the same position. They're just in different locations on our grid. So the next thing we have to do is a translation. So I'm going to click on this and then translate by vector. And the translation one's nice because you can just select it and drag it. So if I select this point and I drag this whole figure, notice it can sit right on top of that blue image, right? So notice I can kind of move this around as much as I want until I change what I'm doing. So if it sits right on top, all right. So let's think about what we did. We had to dilate and then we had to translate. So if I go back to my answer here, it says, what did you do? Well, I dilated by 2. By scale factor equals 2. Then we translated. So we need to figure out how much we translated. So if I go from A, what did I get? How did I get from A to that spot right there? Well, I went to the right 2 and I went down 1. So the rule I can write then is translate by x plus 2, because I'm moving to the right 2, and then y minus 1. And that's all you would need to type for that one right there. So then your goal that you're going to do on your own is, how can I take this figure, again, our original one, how can I make it to match up with this green one? Here's a hint. The green one is smaller than this one, so that means my scale factor is going to be less than 1, and it looks like it might be some type of reflection. So if I want to do a reflection, reflect about a line or reflect about a point, I'll let you figure that out. Okay? Then scroll down. They're going to ask you a question. You can skip question 3. Just click submit. Don't worry about it. Okay? And then down right here, question 4. So question 5 is about ratios and whatnot, but this one right here. So they're asking you to use the distance formula to find lengths. Now we have GeoGebra. We don't have to use a distance formula. They're asking what is the length of this. Now you could use the calculation, but don't worry about that. Just use GeoGebra. So they're asking what is the length. So I only want you to focus on, I know it says GH, but we didn't use that figure. Okay. Let's move this guy out of the way for a second. Let's move this guy. So they're asking for GH, which is this figure here, but I want you to focus on the blue one. So if I want to find the length of the blue sides that are corresponding, I click on this one right here is my angle / distance measure. So AB is 2. So I'd go back over here. AB is 2. Or here. It doesn't really matter where you put it. Then the one that's corresponding to that is right here. That's 4. Notice it's 4 because I increased that amount by 4. I dilated by a scale factor of 4. So that means that every length in my figures, so if I go C to D, that's 2.24, which means that this C to D, which is the same length as this one right here, that should be double that amount. 4.47. And they're rounding a little bit. That's why it's not 4.48. Okay, it's because GeoGebra is doing a little bit of rounding. All right, so that's how you would find all of these different lengths. And then they're going to ask you a question. So the ratio would be, okay, now this is a good point. Now, if I'm going from here to here, that ratio is 2 to 1 or 2 over 1. But if I was going backwards, because remember, for the ratio to do enlargement, it has to be greater than 1. But if I was going from this figure to this figure here, it'd be 1 over 2, because that's a reduction, a 1/2 reduction. So guys, ratios, even though they're written with that colon, you can write them as fractions as well. So 1 to 2 is the same thing as 1/2. All right. So they'll finish writing this up, okay? And then we'll move on to the next few slides. So just taking in the information. Now, here is a good practice question. It says, polygon ABCD is dilated, rotated, and translated. Don't worry about the rotated and the translated. You're focusing on the dilated because they're asking us what is the scale factor. Now, you could use the distance formula to go from here to here and from here to here. That would give you the length of each one. All right. But there's something you could also do, and you can do this while you are taking some of these tests. So if I click on this little grid looking thing over here and I click GeoGebra, all right, it's going to take you to the GeoGebra home website. Now, you feel like you would get lost if you try to look for something here. So all I want you to do in the search bar is type in blank. And what that's going to do is going to take us to a blank grid. See where I'm going with this? Now I can create some of the stuff they're showing us. All right, so I'm going to zoom out a little bit, and I'm going to plot those points that they just gave us. So I'm going to plot a point at 6, -6. Oops, wrong one. It's a blank one. So 6. Make sure that you can drag around here. So 6, -6. Put a point there, and then go back and put a point at 2, 1.5. So 2, 1.5. Right around there. Okay. And then I'm going to use a line to connect it. Got to make sure you're on your arrow. So now I can technically find the length of that using our measuring tool. 8.44. Do the same thing now for this one. Okay, so I did, after I dilated, we need to do 0, -7, and 8, 8. So 0, -7. And then 8, 8. And then let's create that segment. Zoom out a little bit. And find that length. So that's 17. Now, if you right-click this point, you can adjust its location. So if I wanted to be at 2, 1.5, it'll move it a little bit for me. So notice that changed to 8.5 right there. Okay. So they're now asking us in this question, what is the scale factor of dilation from 0, -7 to 8, 8? Well, if I look at these two, if I started off at 0, -7. So this was my original segment, and then I do some translation, rotation, dilation, and I get this. What's the difference in length between this figure and this figure? How did I get from 17 to 8.5? I divided it by 2. So my scale factor is 1/2 for that. So that's how you can use GeoGebra instead of using the distance formula. You can still use a distance formula, but you don't have to. All right, that's kind of the point I was trying to get at there. Last part is the similar triangles. All right, now for this activity, you'd click through it, and it'd be right here. So they're asking, perform transformations to make this blue triangle match up with this green triangle right here. Okay, so if you look at those directions, they're asking, what are you finding? How would you do that? Etc. So sequence 1, sequence 2. So it's 2 transformations. All right, I'll tell you right now, it's a rotation, and then it's a translation. And then they want you to figure out the angle measures. So I want you to take a look at this. So if I want to find angle A, I go to my measuring tool, I click on angle, I click on B to A to C. Now remember, I've talked about this in the past, or if that doesn't work, you go the opposite direction, C to A, B to A. So notice it's 26.7. Now when I look at this diagram right here, I think that D corresponds to A. So if I measure D, because these are similar, I should get the exact same angle measure. Let's see what happens. F to D to E. Boom, same thing. And that goes back to what I was telling you earlier, is that similar triangles and figures have congruent corresponding angles. So that's the main part for this, guys. Don't stress too much on the GeoGebra aspect if you get hung up. The biggest thing is, can you answer these multiple choice questions, because these are what they're going to be like when you start doing your mastery test. Okay, so questions like this guy right here. This is talking about angles. All right, and so then make sure that you read the responses. If they type something in, like if I say 50, they're telling me it's wrong, and they tell me why. All right, so that's important to pay attention to. Sorry for the long video, but there's a lot to cover in this one. Talk to you soon.